Hey everyone, this is part 4 of our Building with Claude API series. And in this video, we're going to discuss about response streaming. Have you ever wondered how, when we give a prompt to Claude, it gives us back the response as a streaming text? See, the text is streaming. It's not waiting for the entire, output to be generated and then given back, but rather, it is actually streaming the response back to us, and that makes it a lot more responsive for end users, right? Because they're not just staring at like a spin wheel or something waiting for the response to completely get generated and then sent back to you. They are seeing the response unfold to them in real time, right? So that's a cool user experience to have. Till now, as we were making use of the Claude API, this client.messages.create, the response was just coming back to us after it fully got generated in the server side. For example, if we run the same prompt of create a funny poem of how Claude is changing software engineering, I've added the exact same prompt over here. Then we make use of this API, client.messages.create. Let's see how long it actually takes to generate the response and give it back to us. Okay, so I'll just run this now. We're just waiting now for the response, right? So imagine how the end user will feel. They would have had to wait for about 5.6 seconds before they could actually see something on the screen. So that's not a really good user experience, especially when we are building these AI powered apps. In this Building with Claude API course from Anthropic, they walk us through the best practices of building, these AI powered apps. Imagine you're building this chatbot. It could either be a web interface or a mobile app. Anytime the user wants to send a message to Claude, for example, they give a prompt, what is quantum computing, right? Now, the API itself, as a best practice, it'll be good to keep it in your server, okay? In the server that we are setting up, in our server, rather than having the API code here living in the client side. We don't want our Claude API key or even any of the Claude API that we are using to actually live on the client side code, which will be shipping to the end user. Whatever request they make, we first send it to our server, which is over here, right? And then our server has the code which would then make the Claude API calls. That's a bit of a best practice to have rather than exposing all the API code that we make use of to talk with our LLMs. So coming back to the challenge that we are facing at the moment, even after having the Claude API code over here, we're still having to send the request using this particular API, which is client.messages.create, and it's basically kind of like a blocking call, right? So you send that response using this method, and you need to still wait for the response to be completely generated in the Claude server, right? And sent back to us. For the prompt that we gave of creating this funny poem, it easily took us about like 5.6 seconds, right? And some responses can easily even take 10 to 30 seconds. Once it is generated, the Claude server would send the response back to our server, and then we send it back to the app, either the web app or the mobile app. Now, how do we overcome this blocking user experience? How do we make it a bit more like what we see in the Claude.ai app, where the text is getting streamed back to us? For this purpose of streaming back the response, Claude exposes this stream mechanism. The way we can make use of it is by means of using this client.messages.stream as a context manager. We're basically passing this exact same arguments that we would pass when we are using this blocking call. We're passing the model, which we pass over here, the max number of tokens, messages, temperature, all those parameters that we would pass here, we can pass it here as well. But then we get this context object, which is a stream, okay? So from the stream object, we can then get the text as and when the text chunks get generated by Claude, okay? And this gives us experience that is much more pleasant for the end user. Let's just see it in action now. So instead of using this mechanism. Let's run this mechanism right now. And we can see in just about 1 second itself, the output has started to stream out, right? So that's much more in line with what we are used to when we are using the Claude.ai's web interface, right? Now let's just break this down and try to get a sense of what is going on, what happens when we do this. So instead of this approach of sending a user message and waiting for everything to get generated and sent back, we make use of this mechanism where, so we still send a user message to Claude. That's what we're doing here. The thing is, it immediately sends us back an initial response. For example, the stream object is basically that initial response, if you will, that we have. From that object, we can start receiving all the different events that come from Claude. We can actually see each of these events that are sent back to us by means of passing a stream flag to this create method. Okay, so let's do that now. I'm going to make a copy of this so that we can modify it. We'll, instead of calling it response, we'll call it stream. And here we'll pass a new flag called stream equals true. And now, as soon as we evoke this method, we immediately, are getting the stream object, just as how we were getting the stream object from this context manager. So that's basically this thing, right? So we got the initial response. As soon as we evoke this, we get this stream object back. And with that stream object, we can stream back all the events that are coming from Claude server. So let's see that in action. For event in stream, let's print all the events. Okay, let's print the event objects that we are receiving. Let's run this now. And you can see that in 1 second itself, see, like all those events are getting streamed out, right? So it's just coming through as and when the events are passed from Claude to us. From the events that are coming back, we can get the respective text chunks that we are interested in. Now, there are all these different types of events that come back to us. Events such as raw message start events, the raw content block start event, block delta event, content block stop event, message delta event, messages stop event. Here is a diagram showing all the different types of events that come back to us. The message start event in the beginning, and then the block start, then the block deltas which carry the text. See, these contain the actual generated text, and then you have the block stop, and then the message delta and message stop. Exact same things that we saw printed over here. So instead of us having to know which event has come and then based on that parse the text, because only the delta event actually carries the text that we are interested in, right? So instead of us having to do all of those things manually, we can just make use of this approach where by means of using the with statement, we get the stream object, and from that we easily can just stream the text out. When we are creating these real-world AI-powered applications, we will hold the response in some sort of a database to maintain the chat history, right? So for that purpose, we have this helper method called stream.getFinalMessage, which will give us the final message object from which you can get the text. I'll first print the entire object to see all the different things it holds. So before we run this, let's just comment out the streaming text print, okay? So let's run. And you can see that since we have commented out the streaming text, we are no longer getting that flow of generated text. It just waits for everything to get done and then the final message is printed out, right? So it's very similar to just calling this approach without the stream flag, right? And you can see that we have received the response as a parsed message object. And from this, we can get the content object. It has this list that in turn has the parsed text block from which we can get the actual text that we are interested in. It also has this usage object from which you can get the input tokens that was used and the output tokens that was generated. So let's just get the text alone by means of using the content object, and since that's a list, we'll just get the first index in that list and dot text. Now if we run this, we'll be able to just get the text alone as our output. It takes about 5.4 seconds to actually give us something, but we get the final out back, right? So we can use these two mechanisms in combination. For the user experience, we can just stream the text back to the user interface, And finally, after all the text chunks are streamed back, we can just store the entire text in some sort of a database by means of using this get final message mechanism. So that's basically how we can stream the response messages back to our user interface to give a better user experience for our end users. Follow along if you're exploring AI for your workflows.